Today we're going to tackle some more difficult geometry-based problems. They're going to tie in perimeter to area, and we're going to learn how to use that information to generate maximum. So it looks like we have someone who's planning a garden. He's going to shape it as a rectangle, and he has 120 feet of fencing. So a good little cheat fact is anytime you see fencing or fence, you need to think perimeter. So that's like saying the perimeter is going to be 120. We want to know what do the dimensions need to be so that he maximizes the area of his garden, so that he has the most room to plant his crops. And then what is that max area? So the important thing to notice right here is letter B is actually asking for K. So even if you're not sure where to start, you want to know, okay, I need to get K. At some point, she wants to know what K is, and then we can go back and answer question A. So we want to make sure that we realize if this garden is adjacent to his house, so here's his garden and here's his house, he's not going to need to fence this side because it is bordered already. So he's only going to fence 3 sides of his garden. So step 1 is I like to establish my formulas. That kind of gives me a foundation to start the problem. And since we're talking about perimeter with the fencing, normally perimeter is 2 length plus 2 width, but because we're only doing 2 sides, we're only going to double one side and keep one of the other side. So it's completely up to you if you want to use W's and L's or M's and Q's or whatever you want. I just use W and L as my variables. So I'm going to establish my perimeter formula and I'm going to establish my area formula. You'll be given perimeter, so in this case it's 120. So we're going to go ahead and put that in for P into the perimeter formula. And then once we do that, we're going to choose, we can either isolate the W or we can isolate the L. So there's me plugging in 120 for P. And I'm going to isolate the L since that way I don't have to create any fractions. So I'm just going to subtract this 2W over. And so L is going to equal 120 minus 2W. And most of the time that's pretty easy to follow. That's not really where students get lost. It's a step after that. So what we're going to do is the whole reason we isolated L is we're going to take this formula and we're going to plug it in for L into the area. I have not used the area formula yet. So the rule with substitution is you have to substitute into an equation that you haven't used yet. So we're going to replace L with 120 minus 2W, and then we are going to go ahead and we're going to distribute and simplify. So we'll get 120W minus 2W squared. And it's always a good idea to put your answer in standard form. So we want to write it in this order. That way we don't make any silly mistakes along the way. And you want to think about your task. You're trying to get K for me. So we want to get the max area. And here I have a formula for area. And this will make a graph of a parabola. So you can actually find K from this parabola. That's the same thing as changing W into H. So if we can get H from this formula, then we can get K. Just keep that in mind. So instead of writing W, I'm just going to change it into H. And that's my step 4. We're going to go ahead and use that opposite B over 2A formula. And so I know that my H will be 30. And then I'm just going to take this H value and I'm going to put it right into my K and H equation. I'm going to put it right in here. Now 30 squared is 900, so I didn't write 30 squared. I just wrote 900 to save a little bit of writing. And then if I simplify that, I'll get 1,800 square feet. That is my max area. So this would actually be the answer for problem B, because B says what's the max area. When they say what dimensions will produce, you want to make sure you realize, okay, instead of W, I changed W into H. And I found that H was 30. So therefore, I can go ahead and say the width that produces max area is 30. So if W equals 30, then I could plug that right into this formula here. 2 times 30 is 60. And 60 plus what makes 120? That would have to be 60. So it doesn't matter which way you went about solving this, you should get 60 and 30 as your dimensions. I don't care which one you call the length and the width, but just remember that whatever letter you have here we just changed that letter into H. So if you have H, you have one of those letters. Just keep that in mind. And then we already got the answer for part B, which is 1,800 square feet. So we're going to do another one, and this time I'm not going to have the picture already done for you. So Sandy Cheeks from SpongeBob is making a petting zoo for her underwater dome. The animals will be kept in a rectangular enclosure. One side of the enclosure is completely bordered by a decorative wall and does not require fencing. She does have 102 meters of fencing, so what is the max area she can provide for her animals? So it's a good idea if you draw yourself a picture. It does say rectangular enclosure, so I'm just going to sketch out a rectangle. And this is going to be the decorative wall, so she's not going to need to fence this side. So if I pick two letters, let's say I want to call this L, then this is L, and then I'll have to make up a letter for this side. So again, you don't have to use L's and W's. You can use X's, P's, Q's, R's, M's, B's, whatever you want. I just like to use L and W. So if we follow our steps, the first thing we're going to zoom in on is that we have 102 meters of fencing. That means the perimeter is 102. So I want to establish my perimeter formula. So if I add up these two sides and the W, I get 102. And I don't want to forget this is an area problem, and I have a formula for area. So that is the foundation my problem is built upon. Then I'm going to isolate a letter. So this, I chose to isolate W by subtracting 2L on each side. Then I'm going to take my 102 minus 2L, and I'm going to plug that in for W right here. And this is what it would look like. Do a little bit of distributing, and I'm going to rearrange it so it's in standard form, and I get negative 2L squared plus 102L. And I want to remember, if I want to find the max area, I can change A to K and L to H. So in order to find K, I need to find H. So that's what we're doing right here. And we are going to get a decimal, and that's okay. We get 25.5 for our H. Then we're going to plug H in for L, and we're going to simplify, and we're going to get 1,300.5 square meters. In the next video, we're going to turn it up a notch and make it a little bit more challenging for you. It's not as simple as just finding the max area of a generic rectangle. There's actually some more information in the problem. So next video, we'll go ahead and tune into that and see what that's like.